Hey everyone, today we're going to talk about architecture diagrams, why we use them, what makes them useful, and why treating them as code artifacts changes the game. We draw diagrams because we need a shared language, a way to show structure, intent, and relationships. There's an old saying, all models are wrong, but some are useful. It's important to remember a diagram isn't the system itself. It's a representation, a way of explaining it to others. The key is consistency. Your diagrams need to stay consistent across different views, from business context down to component design. Whether you're talking to an executive, a developer, or another architect, everyone should be looking at the same model of the system, just from a different viewpoint. Let's talk about some of the standards you might see. There's UML, the Unified Modeling Language. Most people know it for class or sequence diagrams. It's useful for low-level logic, but rarely used now for big relational diagrams. Then there's Archimate, an open source enterprise modeling language developed by the Open Group, the same people who created TOGAF. It's great at the enterprise level, but it doesn't move up and down very well. Once you zoom in, you start to lose clarity for most stakeholders. And finally, C4, created by Simon Brown. It's simple, pragmatic, and it defines 4 clear levels. Context, the big picture, users, systems, dependencies. Container, the logical and physical boundaries, APIs, databases, and services. Component, how each container is built internally. And code, the UML style details at the class level. Most solution architects focus on the first 3, but the key is that they all connect cleanly. I love C4 because it rides the elevator beautifully. You can move from context to component without losing the thread. It's a simple, encapsulated, and universally understandable model. If someone hasn't seen it before, you can easily teach it in 5 minutes. So, that's the theory. Let's talk about how to make it real. Structurizer is a tool built by the same person who created C4. It lets you define your diagrams in code using the Structurizer DSL. You describe your systems once, and the diagrams are generated automatically. The cloud service may be shutting down in September 2026, but the open source tools live on, and you can run Structurizer Lite locally or integrate it right into your build pipeline. So, why bother with diagrams as code? Why not just drag boxes around and lose the chart and call it a day? Because code-based diagrams give you 4 major advantages. 1, traceability. Every change is version controlled. You can see who changed what and when. 2, a review pipeline. You can review architectural changes the same way you review code through pull requests. 3, reproducibility. If your diagrams are tied to a branch or a tag, you can always regenerate the exact diagram that matched that version. And 4, consistency. All diagrams share the same style, colors, and layout rules, no matter who drew them. Sure, you trade a little bit of artistic polish, but what you gain is absolutely worth it. To keep myself sharp and to show my work publicly, I maintain a full diagram pipeline for Fig Technology Solutions. All my diagrams are written in Structurizer DSL, stored in a GitHub repository, and rendered automatically. A helper script runs Structurizer Lite in a container and exports PNG or SVG images on demand. That means every diagram is versioned, reproducible, and consistent. Here's how the repo is structured. GitHub and Structurizer handle setup and runtime. Docs handles the README and any architecture decision records. Export stores the generated diagrams. Lib defines the shared styles and colors so everything looks consistent. Tools holds a Docker Compose file for running locally and the export script. And Workspaces contains the actual Structurizer workspaces for each example. Each workspace has 3 files. Workspace DSL, which is the entry point that ties everything together. Model DSL defines the people, systems, and relationships. And Views DSL defines the actual diagrams you want to render. Each view chooses which parts of the system to show: system context, container, or component. And you can filter using the include statement or highlight as needed. An automatic layout keeps things tidy without spending hours moving boxes around. Inside the model, I break it down like this. We have people, who's using the system and what are they doing? Systems, the core applications or services that actually make up what you're trying to do. External dependencies, any other systems that we rely on. And relationships, how everything connects together. Each element has a name, a type, and a description. Tags define how they render. For example, tags like database allow you to change the way that that particular element is drawn on the page, or external to allow you to show that systems are outside your control. Relationships are directional and labeled with a name and a technology, HTTP, Kafka, or whatever else you're using. Let's take a look now at an example. Let's look at the container view for the social app system in the Panda app. So we'll go into our export, we'll open up Panda, and we'll open up the container view. You can see all of the major components, the API, the database, and the native applications, as well as their relationships. And we can see the same thing here. So we've got our app, we've got our web app and our native app, we've got our API, and then we've got our relationships. Now what you'll notice is that even if you don't define the relationships directly, i.e. we don't define a relationship directly between API and the database or the blob storage or the IAM service, but what we do have are relationships between components of those things. So you can see that in the app, in the API container, we have the DQL service, and we have an app interface and a blobdb interface. And all of those things are tied together. So the app DB, the blobdb, those are what actually talks to the different services. So even if you don't define every link manually, Structurizr will figure it out from the lower level relationships. So your diagrams stay clean and up to date with almost no maintenance. So that's architecture as code in a nutshell. Versioned, reproducible, consistent, and reviewable. When your diagrams live in source control, your architecture becomes part of the build, not an afterthought. Once you've worked this way, you'll never want to go back to static slides ever again. If you want to see these examples in action, check out the Fig Technology Solutions site where I publish all my demo architectures. Thanks for watching, and I'll see you next time.